I'm Mel. My working life, just to give you a bit of background, has been art school, tattoo artist, production coordinator, technical recruiter, Ruby developer, and now developer advocate. And you'll see a bunch of these influences come through in some sort of sad crescendo in this talk at some point. Currently, I work at Buildkite. If you don't know about Buildkite, it's a super flexible, powerful CI/CD platform. We have a hybrid model, which means you run our agents on your own infrastructure and we host and maintain the API plane and UI so you can interact with and see all your pipeline and build information. But enough of that, let's get into it. So today we're going to look at CI/CD through an SRE lens. I will cover some of the issues you might face in CI/CD. We'll take a look at some SRE principles, which I hope you don't mind me covering. It's SREcon, you probably already know them. And we'll look at what SLOs, SLIs, and error budgets are and how we might apply these in a more practical sense to CI/CD. So today's story is a little drama. Well, it'll unfold in 3 parts. There'll be like a terrible thing that happens, then I'll start to pull myself up out of a rabbit hole and together we will look towards a rosy future. So if there's no drama, we're not shipping software, so let's set the scene. Now, this is a new addition to my talk, but I've got a soundtrack to play. And I promised I would, and here it is. Now, before you at me, this is not the right song for the image, but we'll just go with what I've prepared. Oh. Thank you. I'm glad it's a small crowd. I was just testing the water there, but it's good. It's so fun. I like zoos. Anyway, so we have a monolithic code base. We have a gargantuan test suite, and we have microservices for as far as the eye can see. I don't know about you, but that's the software landscape that I am familiar with, and it's very, very complex and very, very difficult to navigate. But we all love a good challenge. We love the highs and the lows. It's not about the destination, it's about the friends that we make along the way. And today is a very, very big day for me. My adventure is coming to a conclusion. I'm about to ship a feature I've been working on for months now. It's tested on my branch. Everything's looking good. I've got the approval. It's going to go to production. So it's green. Make it so. I always say that when I ship, don't you? So my build's kicked off. I've got time for a coffee. My day is looking really, really, really good. I'm feeling good. I get to pick up a new card in a minute. Or do I? So my build failed. Now, this is baffling because when I ran it all on the branch, everything was looking great. Nothing could have gone wrong, am I right? I'm looking through the logs of my build, and it looks like the test that failed isn't even remotely related to the code that I just deployed. And now I'm blocked. Pretty blocked, like Pooh Bear there. And I'm headed down a rabbit hole. So I don't know how you feel about CI/CD. I like CI/CD because I work for Buildkite, so I clearly like it. But as a software engineer myself, I like CI/CD when it's over there doing its thing and I'm over here doing my thing. It's like, I just want to push changes and you're going to make sure they're safe and they're in prod within minutes, even on a Friday. And I don't think that's too much to ask, but apparently it is. And we end up not fully trusting the system as it's supposed to be trusted. We end up adapting our workflows to work with kind of crufty, cruddy, ways of working, and it's just when the CI/CD just doesn't end up living up to all that it promises. So like it says on the label, continuous integration and deployment is the automation of building and testing code. CI/CD allows teams to ship code easily and frequently with a high level of trust that end users won't be impacted by bugs. Well, that's not how it feels to me today. Now, fortunately, Buildkite has a retry failed step button, so it means I don't have to kick off my entire build again, but I'm mashing that button again and again and again, and it just keeps failing. And I just want to deploy my changes. Like, honestly, that's why I'm here. So flaky tests happen to be a thing. I know they're a thing because when I put in the Google search, flaky test memes, there were thousands of them. So I think when we hit a flaky test, instead of resolving that or moving on, we probably create a meme or two. And I'm thankful for that because there's a lot of material out there. But I just remember when I first became a software engineer, pairing with the senior on my team, and I saw there was a smoke test that was kicked off by one step in the build, and it was always red. I think it did some third-party payment integration testing off on the side. So our builds weren't dependent on it, but it still tested something important, and it was always red. And so one day I turned to him and I was like, so why does this smoke test always fail? Yeah, why? And he's like, it's never passed. And I was like, it's never passed. This is me learning how to be the best I can be, absorbing all the information, and then I was just like, why do we run them still? And I seriously thought for a while maybe there was something I was missing, maybe I don't know why, why it's supposed to fail, I don't know. But then from that point on, every time I had a red build, I was like, it's got to be a flaky. It's not my code, it's something wrong with the system. So I think that already established that I couldn't fully trust the CI/CD. And I think for our users, if our users are software engineers, they need to be able to rely on CI/CD to provide them with fast, reliable feedback about the software they're delivering. And when they can't fully trust it, it ends up being our end users of our systems, our customers, who run into problems, really, because we bypass the safety checks that we have before we deploy our code. And so I like rabbit holes. And last year I went down one and I got someone to run a query in our database to find out the impact of retrying a failed step in our build had on users. And these numbers were quite staggering to me. I did not imagine they would be that big. These numbers mean a very real monetary cost is associated with retrying tests. So over a 1 month period, Buildkite users spent a cumulative 9,413 days retrying a failed step. And that is a huge number. A Martian for scale, you can get to Mars and back 17 times in 9,413 days. So that's just Buildkite users retrying steps in 1 month. So if you think about all the CI/CD users out there, the Circles, the Jenkins, all of the people retrying tests and probably rerunning really, really long suites and builds, that's a lot of monetary cost to our companies and also the cost to our environment if you think about the infrastructure and the energy costs of just retrying tests. So big numbers. Besides the time that I've spent hitting the retry button, I've lost my flow. I don't know about you, but when I lose my flow, I go into Slack and I make sure all the white dots are gone from every one of the red. I don't use the keyboard shortcut. I just like getting rid of the white dots. I go into Twitter, see what's been happening. Not much at the moment, but it does take time to get back into the zone, and I've lost the flow. So I don't really need to go on. I'm sure you get the picture. Your teams have probably been in this situation, or you have yourself. But it's an awful place, and let's look at how to get out. How can we minimise the impact of situations like the one that I have just so vividly recreated for you on stage? So it turns out site reliability engineers know a thing or two about ensuring systems are reliable, right? Bit of history, which I probably don't need to give here, but I'm going to anyway. The first SRE team was formed in Google in 2003. They wrote a book called Site Reliability Engineering and How Google Runs Production Systems. It's a very, very good book. I really, really love it, and it's kind of our Bible, right? I'm still baffled as to why. Actually, this is small enough crowd. What animal do you think is on the cover of this book? Anybody? Well, you'd think it was a monitor, but it's not. It's a water dragon, apparently. And I'm like, unless they made that maybe it was a mistake, but you would think that's a missed opportunity that it's not a monitor, I would think, anyway. But besides what you think about the animal, you should read the book. It's very, very good. You can read it for free. So we can't talk about SRE without talking about DevOps. In the Google book, DevOps is defined as a loose set of practices, guidelines, and culture designed to break down silos in software engineering, operations, networking, and security, and that is really it in a nutshell. DevOps Principles encourages us to remove silos and do away with any organisational barriers and friction that might exist between different disciplines. Encourages us to accept that accidents are a normal part of building and maintaining software, which we all know is true, and also encourages us to embrace gradual change, and naturally a CI/CD plays a big part of that gradual change process. And it also understands that tooling and culture are interrelated. So tooling and automation are, of course, an important part of DevOps. But DevOps thinking understands that organisational culture and human systems and processes that are the key to adopting new ways of working and far more critical to success than tooling alone could ever be. And finally, Google's SRE handbook states that DevOps thinking understands that measurement is crucial for success, to breaking down silos, managing production incidents, and that it's essential to clearly and objectively measure and verify reality. So that sounds good to me, because I don't know about you, but I want CI/CD to be very reliable. So there are many examples of SRE principles out there, no real definitive list, but there's some common characteristics that are in any definition out there that we all work towards automation or elimination of anything repetitive, and that's mostly to reduce friction, toil, and reduce cost. That we will do system design with a bias toward reduction of risks to availability, latency, and efficiency. And that we should be able to ask arbitrary questions about our systems and services without needing to know ahead of time what we'd like to ask. So I like that one. But my favourite one of all is avoiding more reliability than what is strictly necessary. So whilst SRE obviously focuses on keeping services reliable, 100% reliability is never the goal, because we know it's unattainable. It's a worthy goal, but it's unattainable. And we accept that mistakes are part of software. So SRE seeks to ensure that systems are only as reliable as they strictly need to be. And defining what is necessary and how reliable things should be, that's a practice unto itself. So that's my little SRE-shaped rabbit hole. Thanks for being in it with me. I still have to get my feature out. So I don't know about you, but when something feels really bad, I go to this website and I'm like, is Mercury in retrograde? Well, it's not in retrograde till the end of December, so it's not that. But if I, inspect my feelings and get true to myself, I understand that we've had some problems for a while. And they keep cropping up when we least want them to, like today. So how do we address these problems? Well, we've all just heard about SRE, so let's look at putting them into practice. So things are bad. We're not going to deny that. They feel really bad. We know we have a problem with flaky tests. We're pretty sad about how slow our builds are, how long we need to wait for a build to kick off. We know it feels really bad, but what do we actually know about the state of things? Well, remember that DevOps and SRE both say that measurement is crucial for success, and that we need to practice observability and have ready access to data and information about our systems. So, we need good metrics as an objective foundation for conversations with people who all agree on them. And we will be able to agree on them because we'll have some hard facts and some solid numbers about the state of our systems. So that sounds great. How does it work in practice? Let's take a look. So, it's impossible to do your job well without clearly defining well. And I think that applies to all sorts of parts of our work. It could be our individual roles. It could be the state of our systems. If you don't know where you sit and what you're aiming for, you can't do it well. So how do you improve things if you don't know how bad they are to begin with? I don't know. But you can use SLOs, SLIs, and error budgets to help you along the way. So SRE uses them to define what's important and how reliable things should be, and how to measure how these goals are tracking. An SLI is a key metric to use, used to indicate whether an SLO is being met. An SLO is a promise that's made in relation to a metric that matters to the users or maintainers of a system. And where an SLO defines a level of unreliability that's acceptable, the error budget reflects for how much or how long the service in question can fail to meet the SLO without consequence. How do we get everyone to agree on what these should be? Well, I'm guessing if you're feeling the pain, others are feeling the pain too. It's a perfect time to start working together to try to improve things. You're going to stop being reactive in favour of being proactive, and you're going to assign metrics and uphold them, and it's going to be amazing. So get in a room, in a Zoom, start building a picture, take stock of your system and get on the same page. What's the system in question? Is it CI/CD? Are you limiting the scope to an application's test suite? Is it its speed, its reliability? Are the stakeholders all in the room? Who uses it? Who maintains it? What's important to them all, and what is or isn't working? Just get on the same page and understand what you all value. So once you have this shared understanding, it's time to agree on the SLOs, SLIs, and some reasonable error budgets. You might want to stop developers waiting around for builds to kick off. This could be a reasonable SLO for you, that builds should start running within 30 seconds. I'll look at this again in a little bit. I've got to speed up because I don't have much time. This is one way that you can calculate your error budget. There is a calculation, a way of working that out. It's 1 minus your SLO percentage. But if you Google how to work out an error budget, there's a ton of information out there, and it's complex actually, and it varies depending on what it is. If it's like a reliability system uptime percentage, it's much easier to calculate that with using that method. So you might commit to developers having commits tested and notified of success or failure in 5 minutes, and your SLI would be total build runtime. And this one here is great when it comes to my problem of flaky tests. This is the test suite should have a reliability of greater than 87%, and your SLI would be test suite reliability score. How do you get the metrics? Many different ways. When it comes to monitoring production systems, obviously Datadog and Honeycomb are the big players, but there are many, many other services out there that can allow you to configure custom metrics. For this total wait time SLI, we have a CLI tool for collecting agent metrics in CloudWatch, AWS, StatsD, Prometheus, all of those sorts of services. We have OpenTelemetry instrumentation built into the agent, so you can send traces and metrics to any services with an OpenTel collector like Datadog, Splunk, Lightstep, all of those. And if you don't use Buildkite, your CI/CD should have these metrics for you. Datadog has a CI visibility product, and you can use Honeycomb to send traces, pipeline tracing. Once you have this SLO being monitored with this SLI metric, you can start tuning agent capacity as the need arrives. If you want developers to have speedy feedback loops, again, this would be build runtime, and we have an API endpoint to get this data, and it's also visible in our UI for each pipeline. And again, your CI/CD should have this kind of data as well. And again, once you have these numbers, you can start tuning it when you've spent your error budget, of course, no sooner. Because Buildkite agents are hosted on your own infrastructure, you can leverage the same cloud-hosted auto-scaling compute capabilities as you would for your production infrastructure, and your pipeline can be optimized to run in parallel across as many agents as needed. We have some customers who scale out to like thousands and thousands of agents when there's lots of jobs to be done. Really speeds up your builds. Unfortunately, parallelization looks like that and not like Speedy Kitty. Sorry to disappoint you if you haven't seen Buildkite's UI. But another method to speed up builds, of course, is to look at the performance of your tests. We have a tool called Test Analytics, and you can access a whole host of information about your test suite health as a whole. You can sort by slowest tests, and gain some really quick speed gains for your builds. In this example, I took a single test that took 35 seconds to run down to just under 3 seconds, which was just by identifying that it was a slow test and swapping out the capybara matcher. So if you think about a 27-second speed gain over a single test, if you applied that across an entire test suite, that's some pretty huge speed gains. Again, this is my SLO that is close to my heart today. My test suite reliability should be greater than 87%. How do I get that SLI? This is Test Analytics again, and you can see that there is a suite reliability percentage score there. And once I have that metric up in front of me, and once the error budget has been depleted, I can start tuning that. But again, I need the number to know that I can start tuning it. You can sort by individual tests in this case. Each test has its own reliability score. And once you've built that, and we've just got a beta feature that is, you get a list of flaky tests. They are 100% definitively flaky tests. And again, you can start whittling those down or dealing with those tests. Again, you need the intel and the insights before you can start to make things better. And Test Analytics is not just to be used with Buildkite. You can use it with GitHub Actions or Circle CI or other things, so it's worth checking out because it's pretty good information that you don't always have about test suite health. So it's horrifying and amazing that we have these metrics. It's horrifying because we know how bad things really are, but it's also amazing because now we're in a position to really improve things. It turns out the test that failed earlier was 100% of flaky tests. I guess it's no surprise because it was nothing to do with my code. But I can see it has a reliability score of 92%. I will chalk that up as one of my error budget spends, and I'll look at it when I need to. Right now I'll quarantine it and just get my feature out. But error budgets are amazing. You can just keep spending like shopping, and while the money's there, you don't have to drop everything. You can resume doing what you want to, what you're supposed to be working on, and you don't have to lose focus. And that's really why they exist. They exist so we can maintain momentum and focus on our work. And it's once that budget's gone, that's when you will all have brokered an agreement on what happens next. It's usually time to stop doing what you're doing, roll up your sleeves and start doing maintenance of your system to get the SLIs back meeting your SLOs. The concept of downing tools to fix a system once the error budget isn't met is a huge point of contention, especially if you're starting to implement this style of working. It's not easy for everybody. Product managers historically find it quite difficult to drop feature development and start doing, maintenance of a system. But I know most engineers experience that tension of how do we stop doing feature development? How do we maintain the growing complexity of our system? This is the way to do that. But yeah, it's important to realize that it's a journey. There are dragons, but it can be tweaked until everybody's happy. It's you iterating. It's not a silver bullet. It requires people coming together, working together, and adjusting expectations. Start small. You could even start with setting an SLO that is the current state of your system, because at least you know where things are at that point in time, and you can start bringing it down later if you're feeling optimistic. But the reality is there's massive gains to be won. You'll be able to iteratively manage the growing complexity of your system, have happy, focused teams with clear goals and tracking against them, and you'll be able to, most importantly, restore trust in CI/CD, ship less bugs, and protect your customer experience, which is the most important thing. I'll leave you with this amazing quote by Charity Majors. She's always on point. I think this really sums up everything. SLOs are a powerful weapon to wield against micromanagers, meddlers, and feature-hungry PMs. They are an API for your engineering team. Thank you. Thank you. I hope I wasn't just telling you things you already knew. I hope you get some new ideas about how you could tackle CI/CD. You've been awesome. This is my Twitter, and I have some stickers if you want to come and get them later. But thank you.
Thanks, Mel.